I don't know if you can believe it, but I can barely believe that this is the last lesson in Science 30. Unbelievable. Anyway, in this lesson 2.2, we continue to look at the other renewable energy sources, and many of them originate with solar energy. So we're going to take a peek at these. So, as nuclear fusion reactions from the sun are the main source of energy for the Earth, it only makes sense that we harness this energy from the sun, right? So there are some direct ways that we harness the sun's light to create energy or to use the energy. And we're going to look at passive solar energy sources and how they're used, how it's used, and then active solar sources, which you probably have heard of, solar panels, right? And then there's some indirect ways that we capture the sun's energy. And we might capture the sun's energy through wind, because yes, the wind is created because of the sun. Biomass, right? This is going to be the burning or the converting to biofuels of recent things that have grown. Hydroelectricity, so water, dams. And then fossil fuels, which we've already looked at. We know these are sources indirectly. Sun has created all of these sources, energy sources for us, so we can harness them. Alrighty, so first off, we're going to take a look at passive solar energy sources. I'm not going to spend a ton of time in this lesson because I have embedded a lot of better videos than what I'm going to be talking about, but I just want to give you a quick overview of this lesson. So passive, using solar energy passively, this is the idea without using any mechanical devices or machines, okay? So it might be having thinking about where your windows are facing so that you get the most sunlight possible coming into your house. Using a greenhouse is an example of passive solar energy being used. And so we're converting that solar energy in so that we get the thermal energy. So we're not getting to electricity when we're talking about passive. Okay, so we're doing things that are going to bring that sunlight in and that heat in, and then try and keep it in the house so we can keep warm. Then there is active solar energy. And active solar energy, this is what you're probably most familiar with. And this is using solar panels or photovoltaic cells, as they're called. So you might use them to actually two different ways. You might use them to heat a hot water tank, or you might use them to create electricity. Okay, so there's two different kind of ways. We're going to focus on the electricity formation. So these solar cells or photovoltaic cells, they're going to convert sunlight directly into electrical energy. Okay, when we are traveling in space, a lot of the power sources in space are using solar cells. You will also see them in quite a few homes now. If you look on roofs of homes around Edmonton or in rural areas, you'll see that. You might have a calculator that has a solar cell in it. You might have a charger for your phone that's a solar pack. I have a great one that I can take camping with me. I just put it inside the window of my car and I can charge my phone while I'm gone. The energy from these can be used immediately or stored later in batteries as chemical potential energy in batteries. How does the photovoltaic cell work? You do not need to know the ins and outs of this. What you need to know is this basic concept here. When the light strikes the surface of the cell, the photovoltaic cell, the atoms lose electrons. So the electrons are moving, and as soon as you have moving electrons, you generate electricity, right? You've got conduction happening. That's all you need to understand. If you want to go in more detail, you can go for it. Now, this video gives you a nice overview of solar voltaic cell technology, how it's converting that sun's energy directly into electricity. Take a look at that one. Also, there's an interesting piece here, if you're wanting to see this new big solar farm that the city of Edmonton is planning on building, it's going to have 45,000 solar panels. It's right in the River Valley. You can read more about those plans here. Again, these solar cells take up space, right? Because they have to have a lot of surface area to capture that sun. So this solar farm, it's actually quite near where I'm living, and there's a lot of controversy around it because it is going to be in the River Valley area, and you are going to be having to cut down or cover up whatever growth is in that area to begin with, to make room for these solar panels. So quite interesting. Nobody wants to see some of this stuff in their backyard, but if we keep using energy the way we're using it, we also have to find the balance of looking for sustainable sources of energy. All right, for each of these sections, we have another breakdown here of the things to consider, pros and cons when you're talking about solar cells. So if you're looking from the ecological point of view, they are renewable. The sun is a renewable energy source, which is awesome. It's always going to be there as long as we're here. There is no gaseous emissions, no particulates or anything like that. However, the PV cells, solar voltaic cells, are made of toxic materials, and they can be hard to dispose of. They do need large amounts of space, like I mentioned. So you'll run into that NIMBY problem. Not in my backyard. Have you heard of NIMBY? If not, look that up. Not in my backyard. So because they take a lot of space, they're kind of like in your face, and they can create that visual pollution that people might not want to see. They are easy to install. If you want to put them into your own house, you could actually have your own electricity generation, which is not like, if you have a coal fire plant, you can't really have your own coal electrical generation going on at home, but you sure can for solar cells. You can get off the grid completely, or you can contribute to the grid. You can actually add energy to the electrical grid and get paid for it. These cells create DC current. They can't, so solar energy, what this is saying is it can't meet all of our demands currently, but within combination of other energy sources, it can help. It is intermittent, so you can only create solar energy when the sun is out, right? And it can be quite costly. However, those costs are starting to come down quite a bit. All right, on to the next energy source. We're looking at hydroelectric energy. Again, so this is also an energy source that is coming from the sun. It's driving the water cycle. So the sun drives that water cycle. Without the sun, you don't get the water cycle, right? So when you've got water in a lake here, it is heated up and evaporated because of the sun. Without the sun, you would not have the evaporation. Okay. That sun is putting all that potential energy into the water, and it's going up high into the mountains, high land, and that's where it's coming down as precipitation. And so that potential energy of the water is going with that water down the stream. So what do? We build dams to control that flow of water so that we can grab that potential energy and use it for our own needs. So the gist of it is you build that dam. That dam has a turbine that the water flows through that turns, and as that turbine turns, your generator turns. Oh, look, you see it again, right? Turbine turns, generator turns, electricity is produced. About 19% of the world's electricity is supplied by hydroelectric energy, so it's quite a high renewable energy source, and it's used in a lot of places in Canada as well. So this is actually a quite interesting story. I highly recommend watching this or doing some research about the Yangtze. So the Three Gorges Dam, it's found on China's Yangtze River. It's over 2 kilometers long. Okay, so just imagine that. The dam itself is 2 kilometers long and 60 stories tall. That is huge. It took 40,000 people 17 years to build this. It produces a ton of power. It says actually twice as much power as all the nuclear power stations in Britain combined, which is used by 60 million people. That's unbelievable. Now, because of the magnitude of this dam, and China's population is really big as well, right? So as soon as they're making this dam, they have to take space because they need to block this river off with their dam, and you can see it floods the higher level area. So over 1 million people behind where this dam is here had to be displaced, right? Find new housing for 1 million people. Can you imagine that? Also, it says because of this dam, it slowed down the speed of the Earth's rotation by a fraction. Just it made that much of an influence on the Earth's rotation. Anyway, I strongly suggest watching this video. Is a very controversial dam to be built, obviously, when you displace people from their homes. But take a peek at that video and learn a little bit more. All right, how does the dam work? So we have the river. You may have a dam, or you may have the river water just diverted through these turbines. So you can set up and use hydroelectric energy in a lot of different ways. So if you're setting it up so it's just diverting water through turbines, it could look something like this. You turn the turbine down here, which turns the generator, which creates the electricity. The next page, this is showing where the energy conversions are. So you need to make sure you understand these energy conversions. And with hydroelectric energy, the original source of the energy is solar energy. That solar energy is being used to evaporate the water and give it the water gravitational potential energy, right? Because it's up here in the clouds. So it's the water's coming down with gravitational potential energy. It's moving, it's turning into kinetic energy. And as it goes through the dam, that kinetic energy is turning the turbine and then the generator. And then the generator creates the electrical energy. Okay. So it's similar to the tidal energy too, but the original source is different, right? So you get this potential energy created in tidal, but it's not from solar. It's because of the moon's gravitational field. Remember that? You might want to go back and review that. All right, this is another excellent video on hydroelectric energy. Make sure you watch that. And then benefits and disadvantages of hydroelectric. Again, for things to consider from the societal point of view, it generates a lot of electricity needed. It can, if you have the resources, it can generate as much as you need. Majority of BC's electricity actually comes from hydro. The same with Ontario. In Quebec, they use a lot more hydro than we do here. So obviously the disadvantage that we talked about society, it might displace people, or archaeological sites and artifacts might be lost because if we're creating a dam. Benefits. So when we're looking at the environmental or ecological benefits, it's a renewable source, right? The water cycle is there. It's a continuous source. It's dependent on the sun. There's no gases being emitted or particles. It can impact aquatic ecosystems. And the flowing water can cause erosion and leaching over time. And it does use quite amount of land as well. Economics, when we look at how much does this cost, super high construction costs. But because you're not putting any fuel in over time, that pays for itself and you get a pretty large energy yield out of that. They do have a long lifespan. And there's lots of places in Canada that could be considered for hydroelectric because we are we're lucky we have a lot of water in Canada, right? If you look on a map, you see water everywhere, lots of rivers. And mountains, which are helpful too to create that potential energy. All right, on to wind energy now. So again, the energy of wind can be taken right back to the sun. The sun is the originates all the wind on Earth. The sun heats up the solar nuclear energy in the sun. Remember, the sun's energy is created by a nuclear energy. It heats up the air molecules, so it transfers the thermal energy to air molecules. Okay, that thermal energy in the air is turned into kinetic energy because as things heat up, air molecules start to move faster and create wind. That wind is then kinetic energy as things are moving faster. And that kinetic energy we grab and get to turn these blades in our turbines. I think this picture is from Pincher Creek. If anybody's been down there, you've seen these. So that wind is turning the turbine, which of course is connected to the generator. So that kinetic energy is turned into electrical energy in that generator. So there are some great places in Alberta where the wind is pretty consistent year-round, very strong, in that Crow's Nest Pass area, where we have some wind farms already set up and in use. So there's lots of wind generators out there. I've been using them for many years, like a long time. We may have been using them for grinding wheat in the past as opposed to creating actual electricity, but you can see some of these different styles of turbines have changed over time. So basics here, how does it work? Your wind comes in, you turn your blades. The blades are attached to the turbine. That is attached to the generator, and the generator is creating the electricity. Now, you'll have transformers, which we talk about, to get that voltage up or down to what we need. Excellent video on how wind turbines work. Make sure you take a look at that. And again, let's look at the benefits and disadvantages. So when we're looking at the environmental perspective, wind is renewable. It is there. And there's no emissions. Disadvantages, it needs a lot of land. You do need a lot of land. It can be dangerous to birds and bats in the area. You might want to do a little bit more research to see how dangerous it is. And there is a little bit of noise pollution, and definitely a visual pollution issue. And again, it's that NIMBY effect that's going to be happening. NIMBY, if I could spell. NIMBY, so not in my backyard. People don't want to see those. When they're looking at the mountains, they may not want to see a whole bunch of turbines. So a lot of people really like to have their energy hidden away, right? So we'll love to use it, but we don't want to see it being produced. So we get that NIMBY effect again with these because they can be out in our faces. Economical, let's look at money wise. There's no fuel that you have to feed it. The fuel is free. It's the wind. We can build them anywhere, really. We just might not have as good of a wind source, but we can technically build them anywhere, and they do last a long time. Now, the wind is not always there. It can be intermittent, right? So some days you'll have no wind and no energy created. Other days you'll have tons of wind and maybe even too windy and you can't run your turbines if it's too windy. They can cost quite a bit to set up, and wind alone will not meet our current energy demands, but definitely can be another source to help us meet our energy demands if we're looking for a sustainable source. All right, the next energy source is biomass energy. Biomass is a fuel that takes the chemical potential energy from plant matter or agriculture waste from recently living sources, okay? So we're not talking about like fossil fuels where plants and animals die and over millions of years we use those. No, this is like we grow them or we've got this waste and we use it right away. So it's very recent. So that's why we consider this renewable, right? Because we can grow these year to year. Some examples of biomass energy include wood, waste like manure, crops like corn and vegetable oils, plants like algae. And so how do we get the energy out of these biomass? We can do it in two ways. We can burn it directly and I'll show you the mechanism in a second, but the same thing, you burn it directly, heat the steam to turn the turbine, to turn the generator, or we can convert it to a biofuel. You may have heard of biofuel or biodiesel or something like that, something like ethanol, and then we can burn that fuel. And so that fuel can be used actually in vehicles as well. So we're not just talking about electricity. There is a place for transportation to be able to use biomass energy. So here's an example of producing electricity from biomass, whatever that biomass might be. The idea is you need to burn it, heat up the water that's going through these pipes. They turn into steam. The steam turns the turbine, which turns the generator into the electricity, and then the steam condenses back and cools down. So you're keeping the system of water intact. You're not letting the water out. But you are burning biofuel, and as you're burning anything, we know that we release carbon dioxide and other particles are emitted. So here is the sequence of energy conversions. Again, biomass is going to start with the sun. Solar energy is how all of these different types of biomasses can even grow or come to be produced. So wood, crops, even garbage, right? Manure, animals, they all depend on the sun eventually if you go down the food chain to the plants. So you take that chemical potential energy that's been stored in the biomass from the sun, so solar energy from the sun, which is really nuclear, remember, nuclear energy from the sun, stored as biomass, stored as chemical potential energy. It's burnt. We get thermal energy when we burn things, heats up the steam, turns a turbine. As soon as we're turning a turbine, that's kinetic energy. Turning the generator creates the electrical energy. You'll see that conversion set was exactly the same as fossil fuels, right? It's the same energy transfers as fossil fuels. The only difference is the substance you're starting with is considered renewable because it didn't take millions of years to be produced. Watch this video, excellent video on biomass energy and how it's used. Let's look at the benefits and disadvantages for society. So one of the disadvantages with biomass energy is that it takes up a lot of land to produce and grow these crops. Okay, so then farmers are going to have to choose between, are they going to grow crops for food or are they going to grow crops for fuel? So we have to be careful, because if we decide to only use biomass as our energy source, it would take up all our land for the amount of energy that we are needing, and we wouldn't have any land to grow our food. So this is a really big concern with using biomass energy. Environmental, we're going to look at the environmental parts. It is considered renewable. There is carbon dioxide and other particulates that are going to be released, but the carbon dioxide can be offset because you're replanting trees or replanting those crops. Because you planted them in the first place. So it's considered carbon neutral because you planted the crops, then you burn the crops, then you plant the crops. So that carbon dioxide gets taken back in when those crops grow, and then it's released when you burn it. So it's kind of this back and forth. It does produce, these different emissions, and there are some solid wastes involved with it. And if we're growing a lot of crops, we know what happens to soil. The nutrients get depleted over time, and so we would probably have to add fertilizers and pesticides, and so that use would increase. Economically, it's readily available. We already know how to grow these crops. We've got them. We can do them on small scale electricity creation too. We don't have to have huge scale for this. And can this meet our current energy demands? No, not totally. It can't do everything for us. It's not enough energy for the whole world at their current rates anyway. But remember, though, we talked about how another way we can use biomass is through biofuels. So we can also take these biomass and convert them to biofuels, which we can use in vehicles, or we can burn to make electricity, just like we would methane gas, right? So, or natural gas. So waste woods, fuel crops, any of these things, plant waste can be converted to ethanol. We can also take waste things like cooking oil, leftover cooking oil. Like if you have a fast food joint, you could actually, there's people that collect the cooking oil and turn it into biodiesel. You can actually, like I've actually done this, made biodiesel. It's super easy to do. And then if you have a diesel engine in your car, you can actually use biodiesel to run your vehicle directly. You don't even need to use diesel. So there's a lot of people, not a lot, but there are people doing that to make your own kind of fuel for your vehicle. Take a look at biodiesel. It's quite an interesting source. And just uses old waste cooking oil, which is going to get thrown out. Lots of energy in there. And then we can also use the decomposing organic waste in landfills. It would convert it to biogas, like methane or something like that. So advantages of these biofuels are that they're considered renewable, right? So like other fuel sources for our vehicles, they're not renewable, all those fossil fuels, but these are renewable. They can help to reduce our dependence on oil and can slightly reduce our greenhouse gas emissions because it is considered carbon dioxide neutral because we're planting and those plants take in the carbon dioxide as they're growing. Disadvantages are they are lower energy molecules compared to other fuels, so they're less efficient in engines for sure. High concentrations of ethanol are toxic to many organisms, so we got to watch for leaks and that kind of thing. And that growing fuel crops reduces the amount of land available for actual food crops to be grown. And I'd say that's probably one of the biggest worries and concerns around biofuels, because it might be much more economical for a landowner to grow crops for fuel than for food. And then we become to worry about our food sources. All right, so there's a great video here on biofuels. Oops, that's supposed to say biofuels. Take a look at this one. It's quite interesting to see. And lastly, I have one page here on the hydrogen fuel cell. They are fuel cells. These are taking in hydrogen and oxygen. So you give it hydrogen as your fuel source and oxygen from the air, and your only thing coming out is water, H2O. So your only product from a fuel cell is water. You may have heard of hydrogen fuel cells being used in cars and buses. So these fuel cells, basically there's a catalyst in there that allows for a reaction so that electricity is produced as well when the water is produced, and that electricity is captured and it runs the car. It's really expensive. These fuel cells are expensive because of the catalyst it uses. So there's still a lot of research going on with these to see if they can be more common in the future. The trick is also, where is this hydrogen coming from? You need to have a clean hydrogen source so that this energy use is still clean. Yes, you might be giving off water from your car's exhaust system, which is amazing. You don't have all that pollution coming out of your vehicles, but where did the hydrogen come from? So what energy went into creating that hydrogen in the first place? But a very interesting source to do a little bit more research on for sure. All right, yeah, and there's a great video here. Make sure you take a look at that video on hydrogen fuel cells. And then lastly, this is an excellent question. I want you to watch this video. Can 100% renewable energy power the world? That's the question people keep asking. Can we get away from fossil fuels for the amount of energy we use right now? Okay, this video does a great job of looking at that and see if this is even possible. Okay? And as technology changes, everything changes. So that is the last lesson in this course. Congratulations, you are nearing the end, and hope you enjoyed. Have a good day. Bye.